AlliedSignal Commercial Avionics Systems of Redmond, Washington is the world leader in the development and production of ground proximity warning systems, or GPWS. For over 25 years, our ground proximity warning systems have been continually refined and enhanced to achieve the highest standard of flight safety available today.
Controlled flight into terrain is the most significant risk in aviation today for air carriers of all sizes and corporate aircraft. Controlled flight into terrain is the inadvertent flight of an airworthy aircraft under control of the crew into terrain. The ground proximity warning computer uses existing aircraft sensors to monitor the aircraft flight profile and terrain. Using this data, GPWS provides alerts and warnings of potential controlled flight into terrain situations.
Terrain. Pull up.
The current family of AlliedSignal ground proximity warning systems includes the Mark V for aircraft equipped with digital avionics, the Mark VI for business, commuter, and regional aircraft, and the Mark VII for aircraft with analog avionics equipment. Analysis of controlled flight into terrain accidents over the past 30 years has led to the development of 7 different situations where GPWS provides alerts and warnings. These alert and warning modes provide both visual indications and voice warnings to the flight crew.
Sink rate. Glide slope. Wind shear.
Mode 1 alerts flight crews to excessive rates of descent when the aircraft is near terrain. Using radar altitude and rate of descent information, the ground proximity warning computer monitors the flight profile when an aircraft is within 2,500 feet of terrain. Should an excessive rate of descent develop for the aircraft's current altitude above ground level, the red GPWS warning lamp will illuminate and the voice alert sink rate will be heard.
Sink rate.
If the rate of descent continues or worsens, a continuous pull-up voice warning will be heard.
Pull up.
As the aircraft recovers from the excessive rate of descent, the red GPWS warning lamp will extinguish and the voice warning will cease.
Mode 2 warns flight crews of excessive closure rates with rapidly rising terrain. Using airspeed, rate of descent, and radar altitude, GPWS compares terrain below the aircraft to the flight path. If terrain rises significantly within 2,000 feet of the aircraft, a closure rate is measured. When the closure rate shows danger to the aircraft, the red GPWS warning lamp will illuminate, and the voice alert terrain will be heard. If the closure rate continues or worsens, the voice call-out will change to a continuous pull-up warning until terrain is no longer a threat.
Terrain. Pull up.
To help ensure sufficient recovery, the red GPWS warning lamp will remain illuminated until the aircraft climbs 300 feet above the altitude where the last pull-up voice warning was heard.
Mode 3 warns flight crews of inadvertent descents and loss of altitude after takeoff or during a missed approach. GPWS recognizes a takeoff or missed approach using aircraft speed, radar altitude, barometric altitude, and aircraft configuration changes. GPWS then monitors radar altitude and barometric altitude during the initial climb-out. Should the aircraft descend, GPWS compares any loss of baro altitude to peak altitude gained. When this difference is roughly 10%, the red GPWS warning lamp will illuminate and the voice alert "Don't sink" will be heard.
Don't sink.
When a positive rate of climb is re-established, the red GPWS warning lamp will extinguish and the voice alert will cease. Once the aircraft has attained 1,000 feet above ground, Mode 3 is disabled. When GPWS again detects a takeoff or missed approach situation, Mode 3 protection is automatically re-enabled.
Mode 4 provides minimum terrain clearance protection in all phases of flight. GPWS will alert the flight crew to insufficient terrain clearance based on airspeed, altitude, rate of descent, and aircraft configuration. Mode 4 protection is especially valuable when the aircraft is on a normal flight path, where excessive descents or closure with terrain are not a factor. To understand the scope of Mode 4 alerts, let's follow a typical flight from takeoff to touchdown. As shown a few moments ago, Mode 3 protection is automatically enabled as the takeoff occurs. At the same time, Mode 4 begins to build a floor below the aircraft during climb out. This floor will continue to build under the aircraft until reaching roughly 800 feet above ground, where it will remain throughout the flight until the aircraft begins initial approach at the destination. The warning lamp will illuminate, and the voice alert "Too low terrain" will be heard.
Too low terrain. Too low terrain.
Once the aircraft is safely back above the protective floor, the red warning lamp will extinguish and the voice alert will cease. During the approach and landing, GPWS monitors airspeed and aircraft configuration. The minimum terrain clearance floor is automatically adjusted as airspeed is decreased. If landing gear is not down and locked at 500 feet above ground, the red GPWS warning lamp will illuminate and the voice alert "Too low gear" will be heard.
Too low gear. Too low gear.
If flaps are not set to landing configuration by 170 to 250 feet, the red GPWS warning lamp will illuminate and the voice alert "Too low flaps" will be heard.
Too low flaps. Too low flaps.
Pilots may elect to disable the flap alerts by engaging the flap override function either prior to or during a flap alert enunciation. This allows landings in configurations other than normal landing flaps with no GPWS flap alerts.
Mode 5 provides protection for inadvertent descent below a glide slope while on an ILS approach. GPWS monitors the flight path in relation to the glide slope centerline while on the ILS final approach course. The Mode 5 glide slope alert is enabled when a nav receiver is tuned to an ILS frequency and receiving a glide slope signal, landing gear is down, and radar altitude is less than 1,000 feet. Should the aircraft descend below the glide slope to a 1.3 dot fly-up indication, the amber GPWS glide slope alert lamp will illuminate, and the voice message "Glide slope" will be heard.
Glide slope.
Glide slope voice messages are initially softer and less frequent than other GPWS alerts and warnings, but become louder and more frequent as the aircraft deviation below glide slope worsens.
Glide slope. Glide
Once a
slope.
correction is made by the pilot and the aircraft is
Glide
returning
slope.
to the glide slope
Glide
centerline, the amber glide slope alert lamp will extinguish and the glide slope voice alert will cease. To allow repositioning below glide slope when visual conditions are achieved, or on localizer-only approaches, pilots may elect to disable the Mode 5 glide slope alert function. This is done by depressing the amber glide slope alert lamp or switch either prior to or during a glide slope alert enunciation.
Mode 6 contains altitude and bank angle call-out functions designed to increase situational awareness for the flight crew. These call-outs are selected by the customer when GPWS is initially installed in the aircraft. The decision height minimums call-out is a function of radar altitude. The pilot sets the radar altitude bug or DH manually, and GPWS provides the call-out minimums at the selected altitude on the approach to landing.
Minimums. Minimums.
Altitude callouts can be chosen from a large menu of possible combinations.
500.
These callouts are provided to pilots as a
300.
means to confirm aircraft position during approach.
100.
These callouts are just an example of
50.
one altitude callout menu. Bank angle callouts are designed to alert flight crews to the possibility of overbanking, which may lead to serious flight path deviation or loss of control. These callouts occur at preset maximum limits tailored to the aircraft type.
Bank angle. Bank angle.
Near the ground, radar altitude is used to advance the bank angle alert, so callouts are given sooner, providing additional time for pilot corrective action.
Bank angle.
The Mark V and Mark VII GPWS offer detection and warning for encounters with wind shear up to 1,500 feet above ground. GPWS uses airspeed, radar altitude, barometric rate, angle of attack, air temperature, vertical and longitudinal acceleration, and aircraft-specific performance information to detect encounters with severe wind shear. When an aircraft first encounters the strong headwinds, decreasing tailwinds, and vertical updrafts associated with the outflow of microburst activity, the amber GPWS wind shear alert lamp will illuminate and remain on as long as the condition persists. Some installations will also enunciate the voice alert.
Caution. Wind shear.
If the aircraft enters the area of microburst activity where headwinds rapidly decrease, tailwinds increase, and vertical downdrafts become severe, the red GPWS wind shear warning lamp will illuminate, a short two-tone siren will be heard, followed by the voice warning,
Wind shear. Wind shear. Wind shear.
GPWS lamps and voice warnings will cease when the aircraft is no longer in the wind shear condition. Recovery should always continue to a safe altitude above terrain.
Ground proximity warning systems provide silent monitoring of flight profiles, increased situational awareness, and timely alerts and warnings of impending controlled flight into terrain. The introduction and use of GPWS over the past 20 years has made a dramatic impact in the reduction of CFIT accidents worldwide. But the goal is to eliminate controlled flight into terrain by constantly improving GPWS capability. To meet this challenge, AlliedSignal now introduces a new level of technology, a new generation of ground proximity warning systems, the Enhanced Ground Proximity Warning System. Using today's state-of-the-art Mark V GPWS as a baseline, the Enhanced GPWS incorporates a worldwide terrain database, a runway database, and aircraft position supplied by GPS or flight management systems already on board your aircraft. Together, these enhancements provide substantial new capability in AlliedSignal ground proximity warning systems to reduce the possibility of controlled flight into terrain. Two new features of the Enhanced GPWS are the Terrain Clearance Floor and the Terrain Display System.
The terrain clearance floor is designed to alert pilots to a possible premature descent during non-precision approaches. Using runway position data, a protective floor is constructed by Enhanced GPWS around the airport. The terrain clearance floor begins roughly 1/2 mile from the runway ends and climbs with respect to terrain at approximately 100 feet per mile until reaching 500 feet above ground level, some 5 nautical miles from the airport. The floor maintains this 500-foot relationship with terrain until reaching 12 nautical miles from the airport. The terrain clearance floor increases again at 100 feet per mile until reaching 800 feet above ground level at 15 miles from the airport. The 800-foot floor is then maintained to a distance of 25 nautical miles from the airport. This construction provides alerts during long, low approaches, while avoiding any unwanted alerts along a normal 3-degree descent flight path. As an aircraft approaches the airport, it now has protection from premature descents into terrain or the possibility of landing short of the runway. This function is always enabled, regardless of aircraft configuration, around every airport with hard-surfaced runways of 3,500 feet or longer. Should the aircraft penetrate the terrain clearance floor at any point, the GPWS red warning lamp would illuminate, and the voice alert "Too low terrain" would be heard.
Too low terrain. Too low terrain.
For specific airports with unusual terrain factors, the terrain clearance floor dimensions or gradient can be modified to provide increased safety margins.
Perhaps the biggest step toward the elimination of controlled flight into terrain is being made with the enhanced GPWS terrain display. For the first time in commercial aviation, pilots can now have a virtual look-ahead display in the cockpit to show any potential threatening terrain. Using a worldwide terrain database, aircraft altitude, and position information, enhanced GPWS displays a plan view of terrain ahead of the aircraft. Terrain can be shown on existing EFIS map displays or on weather radar displays in non-EFIS aircraft.
Terrain is displayed relative to the aircraft altitude in 3 distinct colors using a dot pattern of varying density. Light density green colored dots indicate terrain 1,000 to 2,000 feet below the aircraft's current altitude. Medium density green dots indicate terrain at a safe altitude below the aircraft down to 1,000 feet below. Medium density yellow dots indicate terrain from approximately 500 feet below the aircraft's altitude, depending on phase of flight, up to 1,000 feet above the aircraft. High density yellow dots indicate terrain 1,000 to 2,000 feet above the aircraft. And high density red dots indicate terrain 2,000 feet or more above the aircraft's current altitude. As an aircraft approaches significant terrain, enhanced GPWS looks ahead and provides alerts and warnings to the flight crew. At 1 minute from dangerous terrain, the voice alert "Caution Terrain" is heard twice, and the threat is displayed as a solid, bright yellow color.
Caution terrain. Caution terrain.
This alert will repeat if the threat is still present after 7 seconds.
Caution terrain.
If no action is taken, at 30 seconds, the voice warning "Terrain, terrain, pull up" is heard, and the terrain threat is displayed as a solid, bright red color.
Terrain, terrain. Pull up. Pull up. Pull up. Pull up. Pull up. Pull up.
In a normal flight profile, as an aircraft climbs to altitude, terrain displayed changes color and becomes less dense in appearance because the relative altitude below the aircraft increases. Eventually, the display becomes blank, as all terrain within range is more than 2,000 feet below the aircraft. Conversely, as an aircraft descends toward an airport, terrain begins to show as light-density green dots when it is within 2,000 feet of the aircraft. As the aircraft gets lower, more and more terrain is displayed with increasing pattern density and yellow or red colors indicating terrain near and above the aircraft altitude. The distinct colors and patterns give the flight crew a tremendous new situational awareness to instantly determine where terrain is, above or below the aircraft. A full 60 seconds from potential conflict with terrain, the areas that represent a terrain threat change to be displayed as a solid color. A bright yellow area will replace the dot pattern, and the voice alert "Caution Terrain" will be heard twice.
Caution terrain. Caution terrain.
If no corrective action is taken, at the 30-second point, the terrain areas that
Caution
represent the
terrain.
most immediate threat
Caution
will turn
terrain.
bright red, and the voice warning "Terrain, terrain, pull up" will be heard.
Terrain, terrain. Pull up. 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 Pull up.
Simplicity and utility for pilots are major advantages of the enhanced GPWS and terrain display. Range capability of the terrain display is pilot selectable from 10 to 320 nautical miles, depending on the specific aircraft EFIS map or weather radar displays. Depending on aircraft type, the pilot will be able to select either the weather radar as shown here or the terrain display as desired throughout a flight. Should the terrain display be deselected when a terrain threat is encountered, the display can be configured to pop up automatically, display the terrain threat, and give the voice alert,
Caution terrain. Caution terrain.
The enhanced GPWS terrain display will be fully integrated and prioritized with other alert and warning functions on the aircraft, such as stall warning, predictive wind shear warnings, current GPWS warnings, and TCAS advisories. A capability is also being developed to support presentation and alerting for significant man-made obstacles. This is an important part of enhanced GPWS. An example might be an unusually tall radio tower that penetrates the limits of the terrain clearance floor.
In the next few minutes, you will see two examples of actual incidents where aircraft were within seconds of a disastrous controlled flight into terrain situation. Both incidents have been recreated using AlliedSignal's flight test aircraft, equipped with the enhanced ground proximity warning system. You will see what the flight crews did not see, and you will see how enhanced GPWS would have given a picture of the threatening terrain well before the aircraft reached the dangerous position that could have resulted in tragedy. The first incident took place on a clear, moonless night as an airline jet approached Portland, Oregon. Some 25 miles north of the airport, the aircraft was given a radar vector heading for spacing and was cleared for a visual approach. The crew began a descent from 6,000 feet so as to arrive at a 9-mile final at 3,000 feet. Unlike the simulation you see here, the crew could not see the terrain below since it was such a dark night. They felt they were okay since they could see the lights of the airport and the city in the distance. On the enhanced GPWS display, terrain begins to show as the aircraft is still some 7 miles from danger. As you see, the aircraft was heading directly toward a 4,300-foot ridge. As the descent continues, more and more of the surrounding terrain is displayed in denser dot patterns, indicating closer proximity to the aircraft's altitude. "60 seconds and 3 miles away, the enhanced GPWS displays a bright yellow terrain threat.
Caution terrain. Caution terrain. Caution terrain. Caution terrain.
At 30 seconds and nearly 2 miles, the bright red terrain threat is displayed, and the terrain pull-up warning is given.
Terrain. Pull up. Pull up.
Several seconds
Pull
later,
up.
we hear the standard GPWS Mode 2 terrain
up.
warning,
Terrain. Pull up.
which the crew did receive
Pull
and
up.
respond to, saving
Pull
the
up.
aircraft.
Pull up.
This incident clearly
Pull
shows
up.
the advantage enhanced
Pull up.
GPWS would
Pull
have
up.
provided by displaying
Pull
terrain,
up.
giving much longer
Pull up.
warning times, and greatly
up.
increasing situational awareness for the flight crew. Remember, this happened on a clear VFR night. The second incident also occurred near Portland, Oregon. Unlike the good weather simulation seen here, a heavy jet was flying in instrument conditions. As it was approaching Portland, it was given a radar vector heading and descent clearance from 14,000 feet to 10,000 feet, some 75 miles east of the airport. Unfortunately, confusion between controllers and flight crew over what clearances were actually given and received resulted in the aircraft heading directly toward 11,300-foot Mount Hood. On a 40-mile range setting, the enhanced GPWS display shows no terrain within 2,000 feet of the aircraft's altitude. The aircraft is now below 13,000 feet, and the top of Mount Hood begins to show. As the aircraft gets lower and closer, more of the mountain is displayed. At 60 seconds and 4 miles away, the bright yellow terrain threat is clearly shown, and the display range changes automatically to 10 miles.
Caution, terrain. Caution, terrain.
The flight crew would have heard the warning as we have here.
Caution, terrain. Caution, terrain.
At 30 seconds and over 2 miles away, the bright red terrain threat is displayed, and the terrain, pull up warning is given.
Terrain, terrain. Pull up. Pull up.
In the
Pull up.
actual incident, the controllers and flight crew got the aircraft turned away and climbing approximately 3 miles and 1,000 feet below the peak of Mount Hood. Had the aircraft been equipped with enhanced GPWS, the flight crew would have seen a picture of their situation some 10 miles away and received warnings at both 4 miles and 2 miles. This incident is a classic controlled flight into terrain scenario, in that a number of factors combined to create the situation, and no single action by air traffic controllers or flight crew was responsible. In fact, the flight crew never saw the terrain they missed by only 45 seconds. The increased situational awareness provided by enhanced GPWS would likely have increased that margin by several minutes. It is clear that with enhanced GPWS, incidents like this could be avoided long before drastic action is required to save an aircraft.
Integration of the enhanced GPWS terrain display is already underway on many aircraft types, including Boeing 757, 767, and 747. Integration on the Airbus A320 aircraft is also in progress.
Caution, terrain. Caution, terrain.
Enhanced GPWS is the most effective and advanced technology available to reduce the threat of controlled flight into terrain. In mid-1996, Enhanced GPWS will be available for original installation or as a replacement for your current Mark V GPWS. Early in 1997, Enhanced GPWS will be available as a direct replacement for your current Mark VII GPWS.
With more than 500 million flight hours and over 25 years of experience, AlliedSignal's ground proximity warning systems and the new enhanced GPWS provide state-of-the-art flight safety technology for your aircraft and passengers. For more information, call the flight safety team at AlliedSignal Avionics in Redmond, Washington.